Welcome to our deep dive into the scariest scientific theories that no one is talking about. You know, the kind that keep you up at night, staring at the ceiling and wondering about the true nature of reality. These theories challenge our understanding of the universe and our place within it. Let's explore the latest research and implications of these mind-bending concepts. Okay, folks, buckle up because we're starting with a real doozy, the false vacuum theory. Now, you probably think of a vacuum as empty space, right? But in quantum physics, it's a whole lot weirder. Imagine a valley in a vast mountainous landscape. That valley represents our universe's current state, a stable configuration of energy. But what if there's an even deeper valley, a lower energy state, just beyond the next mountain range? That's the terrifying possibility of a false vacuum. Recent studies suggest that if our universe is in a false vacuum state, it's not necessarily doomed to instant annihilation. Instead, a false vacuum decay might manifest in vastly different ways. Imagine, for instance, a scenario where the decay isn't total. Galaxies far, far away might be swallowed up by the expanding bubble of true vacuum, while our little corner of the cosmos remains untouched. It's a partial survival scenario, but one that raises some unsettling questions about cosmic inequity. Then there's the idea of gravitational stabilization. Gravity, as we know, is a powerful force. It's possible that the very fabric of space-time held together by gravity could resist the expansion of a true vacuum bubble. This resistance might not halt the decay entirely, but it could slow it down, buying our universe precious time. Now, I know what you're thinking. How can we possibly know if our universe is in a false vacuum? And the truth is, we can't say for sure. But here's the kicker. The universe we observe, with its physical constants and laws, seems remarkably fine-tuned for life as we know it. This fine-tuning has led some physicists to speculate that our universe might be just one of many, each with its own set of physical laws, like bubbles in a cosmic champagne glass. But hey, let's not descend into cosmic despair just yet. Let's face it, folks, the universe doesn't hand out participation trophies. And when it comes to the question of life beyond Earth, the Great Filter theory suggests that somewhere along the path to advanced civilization, there's a hurdle so high, so insurmountable, that most life in the universe never makes it. This filter, my friends, could be a catastrophic event, a technological dead end, or even something we haven't even imagined yet. Robin Hanson, the economist and futurist, laid out 9 critical steps in his model of the Great Filter, each representing an existential risk. These steps range from the formation of habitable star systems to the development of complex life and ultimately to the emergence of interstellar civilizations. Now you might be thinking, hey, we've made it this far, right? And you'd be right to a point. We've survived the early stages of planetary evolution, the emergence of life, and even the evolution of intelligence. But that's where things start to get a little dicey. Imagine for a moment that the Perseverance rover, diligently trundling across the Martian surface, stumbles upon irrefutable evidence of independent multicellular life. Sounds exciting, right? Well, not so fast. Such a discovery would mean that the emergence of life isn't the Great Filter, pushing the filter further down the line, closer to our current level of development. In fact, based on our current spacefaring progress, Hanson's model places humanity at step 8, right on the precipice of potential disaster. So, what could this filter be? Well, it could be something as straightforward as societal collapse, driven by resource depletion, environmental devastation, or good old-fashioned human conflict. Or it could be something far more insidious, like the unintended consequences of advanced technology. Think runaway artificial intelligence or self-replicating nanobots turning our planet into grey goo. Chapter 3. Brane in a vat. Is your reality just a simulation? Hold on to your hats, folks, because we're about to dive into the philosophical abyss with the brain in a vat thought experiment. Imagine this. Your brain floating in a vat of nutrient-rich fluid, connected to a supercomputer that perfectly simulates every sight, sound, smell, taste, and touch. You'd have no way of knowing, no way to prove that your experiences weren't real, that your entire world was nothing but an elaborate illusion. Freaky, right? Now, you might be thinking, Neil, this sounds like something out of the Matrix, and you wouldn't be far off. But the brain in a vat scenario goes beyond Hollywood special effects. It forces us to confront a fundamental question. What does it mean to experience reality? Modern interpretations of this thought experiment often delve into the realm of semantic externalism, a philosophical concept suggesting that the meaning of our words is determined, at least in part, by the external world. Think about it. If our brains were truly simulated, our understanding of terms like vat or brain wouldn't correspond to real-world objects. They'd be mere simulations themselves, divorced from their actual reference. This disconnect between our internal experiences and the external world raises some mind-boggling questions about the nature of knowledge, perception, and even consciousness itself. Interestingly, recent advancements in virtual reality technology have breathed new life into the brain in a vat debate. As VR becomes increasingly immersive, blurring the lines between the digital and the real, it's not entirely far-fetched to imagine a future where advanced simulations could create experiences indistinguishable from actual reality. Chapter 4. Brain Collision, Big Splat. Was the Big Bang just a cosmic fender bender? Fasten your seatbelts, cosmic explorers. We're diving into string theory and the brain collision, also known as the Big Splat. The Big Bang is the prevailing model for our universe's origin. But what if it wasn't the beginning, but just one chapter in a larger cosmic story? Enter the ekpyrotic universe model, an alternative to the Big Bang theory. Our universe is a three-dimensional brain floating in a higher dimensional space known as the bulk. Other brains exist within this bulk, each a separate universe. Imagine these brains approaching each other, energy building like a coiled spring. Then bam! The brains collide, creating conditions for a new universe. This collision could explain the uniformity in the cosmic microwave background radiation. Quantum fluctuations during the collision could have seeded galaxy formation. While it sounds like science fiction, it's grounded in serious scientific inquiry. Chapter 5. Ghost Condensate. Theory: is dark energy even stranger than we thought? Prepare to enter the shadowy realm of cosmology, folks, where we grapple with one of the universe's biggest mysteries: dark energy. This enigmatic force, responsible for the accelerating expansion of the universe, has baffled scientists for decades. But what if I told you that dark energy might be even weirder than we ever imagined? Enter the ghost condensate theory, a mind-bending extension to dark energy models that proposes the existence of a strange, ethereal substance permeating the cosmos. Now, this isn't your typical matter or energy. This ghost condensate, as it's called, has a peculiar property. Its energy density remains constant even as the universe expands. This constant energy density, my friends, could be the driving force behind the accelerated expansion we observe. But here's where things get really interesting. The ghost condensate theory suggests that this exotic substance possesses a sextic dispersion relation. Now, I know that sounds like something out of a physics textbook, but bear with me. This unusual property means that the pressure exerted by the ghost condensate is negative and proportional to the sixth power of its energy density. This negative pressure, my friends, acts as a sort of anti-gravity, pushing the universe apart at an ever-increasing rate. Now, the implications of this theory are nothing short of profound. For starters, it challenges our understanding of general relativity, Einstein's masterpiece, that describes gravity as the curvature of space-time. The ghost condensate theory introduces the concept of exotic fields that mimic the effects of dark energy without the need for modifications to general relativity. These theories may sound like science fiction, but they are grounded in serious scientific research. They represent the cutting edge of our understanding, pushing the boundaries of physics, cosmology, and even philosophy. As we continue to explore the universe, who knows what other mind-bending concepts we might uncover? Thanks for watching, and don't forget to like, share, and subscribe for more fascinating content.